For centuries, we've looked up and dreamed of beauty beyond our world. We imagined skies of gold, oceans of fire, worlds wrapped in light. But we didn't need to imagine. The beauty is real. It's in the silent canyons of Mars, where dust storms swirl like ancient breath. In the deep blue storms of Jupiter, a giant that has watched the eons pass. In the golden rings of Saturn, a cosmic halo forged from ice and time. And from the frozen moon, Enceladus, where fountains of water blast into space, backlit like diamond rain. On Titan's hazy shores, rivers of methane carve alien landscapes. Io burns with volcanic fury, a world painted in sulfur and fire. Europa hides an ocean beneath cracked ice. A secret sea that might hold life. Neptune drifts in cold blue silence, a stormy jewel at the edge of the sun's reach. Even Pluto glows with quiet grace, a frozen wanderer in the dark. And from afar, we see ourselves. A pale blue dot among wonders, fragile, alive, ours. This is not fantasy. This is our solar system. A gallery of light, motion, and mystery waiting to be seen. Earth is the only known living planet in the solar system, a dynamic world shaped by air, water, and life. Its oceans cover over 70% of the surface, regulating climate and hosting vast ecosystems. Rainforests, like the Amazon, act as global lungs, producing oxygen and absorbing carbon. Coral reefs, though covering less than 1% of the seafloor, support nearly 25% of marine species. Weather systems dominate the atmosphere. Thunderstorms can release energy equal to multiple nuclear bombs. Near the poles, auroras form when solar particles interact with Earth's magnetic field. Mountains like the Himalayas were formed by tectonic collisions, still rising today. Deserts such as the Namib are shaped by wind over millions of years, creating intricate dune patterns. Sea ice in the Arctic plays a critical role in reflecting sunlight and regulating global temperatures. Human activity is now visible from space. Cities like Tokyo glow brightly at night. Volcanic activity, like in Iceland, reshapes landscapes and releases gases that build atmospheres. Glaciers in Patagonia and elsewhere are retreating, clear evidence of climate change. Dust storms from the Sahara can travel across oceans, fertilizing rainforests with minerals. From orbit, Earth's atmosphere appears thin, a fragile shell protecting all life. Together, these systems make Earth not just beautiful, but uniquely habitable. Io is the most volcanically active body in the solar system. Its surface is covered in sulfur, giving it bright yellow and red colors. Volcanoes here can erupt plumes over 300 kilometers high. Lava lakes glow with intense heat, hotter than any on Earth. Without an atmosphere, lava fountains shoot straight up in perfect arcs. Sulfur crystals form strange patterns, shaped by constant eruptions. Some mountains on Io are taller than Mount Everest. Infrared data shows multiple hotspots, proof of constant activity. A thin atmosphere of sulfur dioxide surrounds the moon, easily lost to space. Jupiter looms in the sky, its gravity driving Io's volcanoes. At night, glowing lava is the only light, a world of fire and shadow. Ash falls back to the surface, building new layers with each eruption. As Io orbits, it casts a shadow on Jupiter, like a dark spot on a giant. The heat comes from tidal forces, Jupiter's gravity squeezing the moon. This constant flexing melts rock, fueling eruptions that never stop. Saturn's rings are the most extensive ring system in the solar system. They stretch over 280,000 kilometers, but are less than 100 meters thick. The rings are made of billions of ice particles, from tiny grains to house-sized blocks. Sunlight creates bright and dark bands based on particle density. The Cassini division is a major gap caused by gravitational resonance with moon Mimas. The F-ring has a braided structure shaped by two small shepherd moons. Ripples in the rings show past disturbances, like waves from a dropped stone. Saturn's shadow moves across the rings, changing with its orbit. When backlit, the rings glow due to tiny dust-scattering sunlight. Moon Daphnis orbits inside a narrow gap, pushing ring material into waves. Some ice falls into Saturn, a phenomenon called ring rain. The rings are not solid. Particles orbit at different speeds, depending on distance. The Cassini spacecraft once flew between Saturn and its inner rings, a historic pass. Inner particles orbit faster than outer ones, creating shear and structure. These rings are young, likely less than 100 million years old, and may disappear in the future. Titan is the largest moon of Saturn and the only moon with a thick atmosphere. Its haze is over 200 kilometers deep, made of complex organic molecules. In 2005, the Huygens probe landed here, the first touchdown in the outer solar system. The surface has rounded ice pebbles shaped by liquid flow. Large seas of liquid methane exist near the poles, like Ligeia Mare. Rivers of methane carve channels, similar to rivers on Earth. Vast dunes cover the equator, made of frozen hydrocarbon sand. Mountains are composed of water ice, eroded by methane rain and wind. Methane clouds form and rain, but the drops fall slowly in low gravity. Kraken Mare is the largest sea, bigger than the Caspian Sea on Earth. Sunsets here are dim, sunlight filtered by orange haze. Radar maps reveal lakes, dunes, and mountains hidden beneath the clouds. Beneath the ice, a global ocean of liquid water may exist, warmed by tidal forces. Organic molecules form high in the atmosphere and rain down like snow. Titan is alien, yet it shares more with Earth than any other world. Enceladus is a small moon of Saturn, just 500 kilometers wide. At its south pole, deep cracks called tiger stripes cut through the ice. From these cracks, geysers blast water into space over 200 kilometers high. The Cassini spacecraft flew directly through these plumes, collecting samples. The particles are mostly water ice. Some contain organic molecules. Beneath the surface, a global ocean of liquid water lies under 20 kilometers of ice. Hydrothermal vents on the seafloor may provide energy, like those on Earth. The surface is young and bright, constantly resurfaced by ice fallout. Plume material feeds Saturn's E-ring, the widest ring in the system. Heat maps show the tiger stripes are warmer, proof of internal activity. Tidal forces from Saturn flex the moon, keeping the ocean from freezing. Molecules like methane and hydrogen have been found, possible signs of chemistry. In that dark ocean, life could exist, using chemical energy, not sunlight. Future missions may drill through the ice to search for life directly. Enceladus is small, but it may hold one of the biggest discoveries in science. Mars is the most explored planet beyond Earth, a cold, dry world with a rusty surface. Valles Marineris is the largest canyon in the solar system, 10 times longer than the Grand Canyon. Olympus Mons is the tallest volcano, 3 times higher than Everest. Dust storms can cover the entire planet, lasting for weeks or months. Rovers like Perseverance are searching for signs of ancient life. Jezero crater once held a lake, fed by a river delta now dry. Wind shapes dark dunes, creating patterns that shift slowly over time. The polar caps contain water ice, layered with dust from past climates. The soil is fine and red, rich in iron oxide or rust. Sunsets on Mars are blue, due to how dust scatters sunlight. Rounded pebbles show water once flowed, smoothing rocks over millions of years. Gullies on slopes may form from seasonal ice melt, not liquid water today. Ice lies just below the surface, a resource for future astronauts. Phobos orbits Mars every 75 hours and is slowly breaking apart. Mars was not always dead. Long ago, it had rivers, lakes, and possibly life. Jupiter is the largest planet in the solar system, more massive than all others combined. Its atmosphere has dark belts and light zones, driven by powerful jet streams. The Great Red Spot is a storm larger than Earth. It has lasted for at least 400 years. Smaller storms form and merge, some lasting only days. Lightning strikes deep in the clouds, thousands of times stronger than on Earth. At the poles, giant cyclones arrange in a perfect pattern, each bigger than our planet. The Juno spacecraft orbits close to Jupiter, surviving intense radiation. Jupiter has no solid surface, just layers of gas and liquid getting denser with depth. Clouds are made of ammonia, ammonium hydrosulfide, and water, forming colorful bands. Auroras at the poles are the brightest in the solar system, powered by magnetic energy. Its magnetic field is the largest structure in the solar system, stretching beyond Saturn's orbit. Volcanoes on Io feed charged particles into this field, creating a glowing ring. Jupiter's shadow is long. Its moons pass through darkness every orbit. The atmosphere is chaotic, with eddies and waves forming at every scale. Jupiter is not alone. It has over 90 moons, shaping the environment around it. Europa is one of Jupiter's largest moons, and one of the most intriguing. Its surface is covered in cracks and chaos terrain, signs of a shifting ice shell. Long fractures suggest the ice moves, pushed by tides and heat from below. Water plumes have been seen erupting, shooting tens of kilometers into space. Hubble detected these plumes in ultraviolet light, possible evidence of activity. Beneath the ice, a global ocean may hold more water than all of Earth's oceans. Hydrothermal vents on the seafloor could provide energy, like those supporting life on Earth. Jupiter's gravity pulls on Europa, flexing the moon and generating internal heat. The surface is cold and bright, but the ocean below may be habitable. Salty water may exist in pockets, close to the surface, stained red by minerals. The Europa Clipper mission will arrive in the 2030s to study the moon in detail. Future landers may drill through the ice to search for signs of life. In that dark ocean, microbes could exist, using chemistry, not sunlight. From Europa's surface, Jupiter fills the sky, a constant, giant presence. Europa is frozen on the outside, but alive with possibility underneath. We've traveled from Earth to the outer solar system, to worlds of fire, ice, storms, and hidden oceans. Some, like Europa, may have liquid water, just like Earth. Others, like Mars, show signs of a wet past, and maybe life. Even moons like Enceladus and Titan have active geology and chemistry. Saturn's rings are not eternal. They may vanish in a few 100 million years. Jupiter's Great Red Spot has lasted for centuries, but is now shrinking. Titan has rivers and lakes, but they flow with methane, not water. Io is the most volcanic world, heated by Jupiter's gravity. And beneath Europa's ice, life could exist in total darkness. Missions like Europa Clipper will search for answers in the 2030s. Scientists are studying every clue, from plumes to salts to heat, and every child who looks up keeps the curiosity alive. The most beautiful place in the solar system may still be waiting to be discovered.